Hey everybody, we are back and we are going to be talking about chromatography today. We are finally going to get to do an actual lab in class. It's been a little while, so I know the first units have been a lot of information, and we will actually start to get to pick up some lab stuff now. Not necessarily a ton of particle diagram stuff that you can do with like atomic radius and ionic radius as far as labs go. So we're actually getting into some actual physical property stuff. So I'm excited for that. So anyways, we're going to be talking about chromatography. Chromatography, and you've probably heard of it before because if you took chemistry with us, you have done the chromatography with food dye lab. But what ends up happening is that chromatography is a process that we use to separate components of a mixture. So you've got this unknown combination of a bunch of different substances, and then you need to figure out what is in there. This could be whether you have a bunch of different components in a plant, or you have them in a dye, or just a sample that you're testing. And so chromatography will help us separate those out. The way that chromatography works is that your mixture is dissolved in something called the mobile phase. And the point of the mobile phase is that they are going to take your substances and then hopefully kind of start to dissolve them. And again, if we think about what we've been talking about, polarity is going to be really important here because it'll be able to dissolve some things well and not others. And then what it does is it takes your mixture and it pulls it through something called the stationary phase. And the stationary phase could be something like a piece of paper. It could be a silicon-based solid column. It could be a layer of substance on a piece of glass or a piece of plastic. And there are a bunch of different ways that you can do that. And so you will see chromatography used in a bunch of different ways. We are going to see it using paper chromatography, but there are four main types. And honestly, there are way more than four types, but what we typically see are liquid chromatography, gas chromatography, thin layer chromatography, and like I said, our paper chromatography. Now, paper chromatography is definitely the cheapest of the bunch, which is why we are doing it. We don't exactly have a GC gas chromatography machine just hanging around, but we understand that there are different types besides what we're going to be doing. Now, you've probably seen this before, but what ends up happening is when we do paper chromatography, you get a sheet of paper. Now, can't just be any type of sheet of paper, so you can't just throw like a piece of computer paper in there. You need something that's going to soak up water pretty easily, so it needs to be a pretty absorbent piece of paper. You could use specifically chromatography paper, or even like a coffee filter works, as long as it's kind of white so you can see the color changes on there. You just want something that's going to really pull the liquid that you are trying to use to dissolve your mixture in, so your mobile phase. And what you do is you draw a line in pencil at the bottom. And the reason why we do pencil is because pencil is not going to be dissolved in any substance that we test. So it's just going to stay nice at the bottom of the little strip of paper. And then what you do is you apply a small sample of your mixture, or if you have a big enough sheet of paper, you can put multiple samples on one piece of paper. So you could have up to, some of the papers that they sell are pretty wide, and you can have several dots on there. Now, this particular setup here that they have is that they have an unknown X, and then they have four things that they think X could be made of, and so they're going to be identifying them. And then what you do is you hang your paper in a container that has water, and the trick is that you want this one we usually use water, but it just has to be a solvent. So it's just anything that's going to be doing the dissolving. And the trick with this is that you have to have the solvent below the dots here, because otherwise the dots will dissolve into the solvent and it'll wreck your mixture. So you have to make sure that the dots are above the solvent line, and then all you have to do is kind of just give it time. And then what will happen is, because the paper is absorbent, it will draw the mobile phase up, and then once the solvent hits here on your dots, it's going to pull potentially that substance up. And what you get is something called a chromatogram. So a chromatogram is the result of the pulling apart of those different things in the mixture. So what you're seeing on the right side here, that is an example of one substance that was made of three different components. So what you see down at the bottom here is typically the remnants of the stuff that's left over when this particular thing is made. It's probably an ink. And then you will see here that there is a yellow dye or a yellow color, a red color that makes up this substance, and a blue color. And they separate out at different distances based on the similarities that they have to your mobile phase. And we'll get into that in just a minute. The calculation that goes along with a chromatography of this type is something called the RF value. And RF stands for retention factor. So it's how well was this thing retained as it moved up with your solvent. And it is a unitless number, and you have units in the calculation, but the actual answer comes out as it should come out as a decimal with no unit on it. And what ends up happening for the calculation is it is the distance traveled by the component divided by the distance traveled by the liquid. So you'll see a line drawn up here at 6.5 centimeters for the water level. And then what we have to do is we have to measure the distance from our starting point up to the middle of the dye band color. So we aren't going to go to the top of the solvent or the top of the pink or the top of this. We're going to go to the middle of those dye splotches to get our measurement there. Okay, so if I want to calculate the RF value for the yellow band here, what I'm going to do is I'm going to take my ruler, and in our lab I've taken the pictures and I have the ruler there for you ready to go. You're going to measure from the start where the dye was up to the middle of the band, which we're going to estimate at approximately 2.5 centimeters. Okay. What you're going to do then is you're going to divide that by how far the water level traveled here. And that is going to be 6.5 centimeters. And so when I divide those two, the centimeters cancel out, and I am left with an RF retention factor value of 0.38. Okay, so the closer to 1 your RF value is, the more that dye traveled along with your solvent or your mobile phase. We can change the solvent. So in the lab that we are going to do, you're going to have water as a solvent, and then we are going to rerun it with acetone as a solvent to see if we get any differences with our substances at all. So this is kind of the calculation that you're going to be doing for that. What that tells you is that it tells you what individual color components make up a mixture, because in our case, we're going to be testing inks. What ends up happening, like I said, is that they are going to split based on their similarity to the mobile phase. So what ends up happening is that the further the substance travels along with the solvent, the more like that solvent it is. So if you have something that's a very polar solvent, the most polar components will travel the farthest with it, and the least polar components are going to stay down towards the starting point. If you have a nonpolar solvent, the nonpolar solvent is going to pull the most nonpolar components with it, and then the polar stuff is going to stay at the bottom. So it kind of depends on what substances you have for your solvents, but just remember that the longer it stretches up, the more similar it is to that solvent. So in the case of this particular chromatogram here, the yellow is going to be our least polar because it travels the least with water, and our blue is going to be the most polar because it's traveled almost the entire way up with the water. So it's got a polarity that's very similar to water, whereas yellow's probably not as much. In our lab, you are going to be taking a look at some different pen inks to solve a crime. And so you're going to have to calculate the retention factor for those different components of the ink and figure out which substance is going to be, or which suspect is going to be the one who committed the crime. Retention factors in general are pretty consistent between different trials of the same substance. So if I take a couple different substances and I run it over and over again, the retention factor should be the same if I have the same ink component. So each dye or pen or marker or whatever that we run is going to have distinct different color bands based on the different types of dyes they use for their given components. So if you are having any trouble, please make sure you ask questions. If you are feeling good about it, just go ahead and do your lab, and we will hopefully do well on it. Good luck.